Okay, welcome back, kids. Now we are working on our second lesson in Unit 6, so we're talking about 6.2. So today we're going to be identifying what we call points of concurrency. Okay, so that's a new word that we haven't used before. So our essential question is, how can you identify those points of concurrency? So what does that all mean? Well, let's talk about it. Okay, so, excuse me, concurrent lines. What does concurrent mean? Okay, so current, like you might think, is the same, right? Current events. Con, meaning like the Spanish is with, right? So concurrent lines is when three or more lines, segments, or rays intersect at the same point. Okay, so they all intersect right there. So that's our concurrent lines. Okay, so these three are concurrent lines. Okay, so the point where they cross is called that point of concurrency. So this is point P. So our point of concurrency is point P. Okay, now the concurrent lines that we would say, it's going to be this one, right? This one and this one. So how do we call this? This is actually this is sorry. That's supposed to be over here. That's supposed to be over here, right? So this one we're going to call line A, right? So line A. Okay. Then this one is line B, right? So line B. Okay. And line C. Okay, so these are all concurrent lines, so they intersect at the same point. That point of concurrency is where they all meet, so that's going to be point P. Okay, so that's the basics of that. Those vocabulary words. All right, so let's talk about some other things. All right, so last time we talked about special segments. Now we're going to go into more in depth. So the first one we're going to talk about is altitude. Okay, so this is a vocabulary word. What's an altitude? Okay, altitude is kind of like what you think of like an airplane, right? We would say altitude. Where's the altitude of the airplane? Well, it's how high it is compared to the bottom, right? So an altitude, we're going to describe it as a perpendicular. So perpendicular means at 90 degrees, right? So perpendicular segment to the vertex. Okay, so if we see over here, this is called a vertex, right? Okay, and we say perpendicular segment. So perpendicular means makes a 90-degree angle. So we're going to just bring it straight down because that's a 90-degree angle right there, right? So that's what an altitude is. It's a perpendicular segment to the vertex. So straight up and down means perpendicular, right? This and this are perpendicular, and it goes to the vertex. It's called an altitude. Okay, so that's the first type of line we didn't talk about last time that we're going to use for today. All right, so we're going to talk about point of concurrency in triangles. So it depends on how you draw it. Depending on how you draw it, they're going to cross at different points. So let's start with the first one. Okay, this first word is called circumcenter. Okay, circumcenter is a point of concurrency, and it's formed by three perpendicular bisectors. Okay, so what did we talk about last time? What's a perpendicular bisector? Okay, well, we know perpendicular means that it crosses at 90 degrees, right? And then the bisector means at the midpoint, right? That's what we practiced last time, right? The midpoint, and then it goes at 90 degrees. That's the perpendicular and bisector. Bisector means the middle. All right, so let's go ahead and draw it in here. All right, so let's look at this side first, right? So we said it's at the midpoint and it goes perpendicular, right? So let's look on this bottom one right here. The midpoint is probably right about there, right? Okay, so now let's go. You said perpendicular, so let's just draw it straight up. Okay, and we're going to put that mark there. That tells us that it's perpendicular, right? Okay, so now let's look at this line right here. Okay, so let's go like right in the middle. Now, first off, actually, back here, I'm going to label that that's the middle, right? I know that's the middle, right? I know that's the middle if this length is equal to this, right? That's what the middle means. It's right. We have the same thing on both sides. So it's in the middle, and this tells us it's perpendicular, so that's why it's a perpendicular bisector. Okay, so now let's look at this side. Okay, so this, let's first off label these two being equal. So since we use one hash mark here, let's use 2 for this side, right? So if this side is labeled by 2, this one's also going to be labeled by 2, right? So this one and this one are equal, and now we see this one and this one. So now let's draw a line perpendicular to this. So it's going to be at a 90-degree angle, so it's kind of weird. It's going to look kind of like that. Okay, it's going to go, you can kind of turn your paper if it helps you can kind of turn your paper, I don't know, I don't want to mess it up. You can kind of turn your paper like that to see. Okay, so then that's that. Now let's do the third one, all right? So this side, where's the middle at? The middle would be right about like there, right? Okay, so now let's go ahead and label these two sides being equal so we know it's the middle, right? So we can say like this one is 3, right? And that one's 3. So we know that this is the same length as that, right? This is the same length as that. This is the same length as that. That's perpendicular. That's perpendicular. Let's also do a perpendicular on this. So it may look a little weird, but it would go just like that, right? So these are perpendicular bisectors. Now if we notice, they all cross right over there. Okay? So where that crosses, that's called our circumcenter. Okay, so the circumcenter is where those 3 perpendicular bisectors cross. Okay? Now the thing about this that we'll practice next time, it's equidistant. Okay, this circumcenter is equidistant from the vertices of the triangle. Okay, what do vertices mean? Vertices are those corners, right? So we can think of it as corners. Okay, so it's equidistant from the corner. So this is equal to this, which that's a bad picture, but that should be equal to that as well. All right, so the perpendicular bisectors are what creates it. Okay, so the circumcenter is going to be what we're talking about. All right, so the congruent segments are from the vertices to the corners. Okay, so those are these right over here. Okay, so next, incenter. Okay, so we talked about the circumcenter. That's by the 3 perpendicular bisectors. The incenter is created by 3 angle bisectors. Okay, so we talked about what angle bisectors were last time. Okay, so angle bisectors, we know the bi means it 2, sectors means 2 sections, so it divides the angle into 2 smaller equal angles. Okay, so we said the angle bisector divides an angle into 2 smaller equal angles. All right, so let's look over here. Right, we know that this is the angle, right? So let's start right there, and we're going to draw. I can do that better. Let's draw kind of like right down the middle, right? And we're going to show that this one equals this one, right? By doing one arc on each one, right? That's a curve on that one, and it's a curve on the other, right? We're showing that these two are equal. All right, so now let's do this one, right? So kind of estimate, let's draw right down the middle on that one, right? Now, since this angle is different from this, let's use 2 arcs on this one. Okay, so we're going to say 2 arcs on that one. And since this is equal to this, let's also put 2 arcs on that one. Okay, so that's how we show that this is dividing it into 2 equal angles. Okay, now the third one. Hey, this one right over here. Let's just draw that as well as we can. If we notice, it's going like right there, right? And we said that this angle equals this one, so let's put 3 marks on that one, right? And so if this angle equals this, we're also going to put 3 on that one. Okay, so these are 3 angle bisectors, and it creates that point right over there. So on this one, though, these angle bisectors, right? So on this, let me do this to help us out. Okay, so this one, we said that it's equidistant from the vertices, right? So here to here to here is all equal. Okay, so that's equidistant from the vertices. All right, now on this one, this is equidistant from each of the sides. So these are equal on this. So equidistant from the sides of the triangle. So that's the difference. This is equidistant from those corners, even though we didn't use those, right? We didn't draw lines there. From this distance to here, this to here, and this to here are equal. Now this one says those sides are going to be, you're going from here to the side are going to be equal. Okay, so if we actually measured that. All right, but it's created by those angle bisectors. Okay, so that's our second one. So that's called the incenter. Okay, next we're going to go into the centroid. Okay, so centroid, that's created by three medians. Okay, so we talked about medians last time. Remember, median is like the middle median in a street, right? So the median is right in the middle. So it goes a segment from the vertex to a midpoint. Okay, so from the vertex to the midpoint. All right, so let's look at the vertex, right? That's one, that's the second, that's the third. So vertex to the midpoint means the middle. So the middle of this and this, right, would look like right about there. Okay, so I'm going to label it like that and that. That shows it's the middle, right? Okay, and then let's go from that vertex to there. Okay, so that's our first one. All right, so now let's do this line right here, right? So the middle of this side would be probably right about there, right? Now, since this side is equal to that one, let's go and label this side with 2, and then let's label that segment with 2, right? Because we don't want to say that this is necessarily equal to that, right? But we know this is equal to that, this is equal to that. Okay, so now let's, we said from the, goes from the vertex to that midpoint. So from this vertex to that midpoint. So let's draw that in. Okay, next our last one. All right, so let's think about this last side right here. So we said it goes from the midpoint. So let's say the mid right there. Let's tell everybody it's the midpoint by labeling that this side is equal to that one. We're going to do 3 on that. Okay, now once again we said from the vertex to that midpoint. So let's go ahead and draw there. And as it turns out, they did cross, as we expect. Now that one is called the centroid. Okay, so this is called the centroid, and this one was called the incenter. Okay, so now the thing about this one is that it's located 2/3 of the distance from the vertex to the opposite side. Okay, so it's what we call a 2-to-1 ratio. What that means is this is 2 to every one of these, right? So in other words, this is twice as long as this. Okay. Similarly, this, right, is half of what this is, right? That's twice as long. Same thing. This one is going to be twice as long as this one. Okay, so that's the thing. This, whenever it creates, say we had 3 parts, right? So this one is half of these two, or this is double of what that is. And we'll practice that more next time. Okay, but that's the main thing. A centroid is created by those 3 medians. Okay, so the centroid is what we're talking about on that one. Okay, so now our last one's called the orthocenter. Now the orthocenter, that's created by those altitudes that we talked about. Okay, so that's formed by altitudes. Okay, and we described altitudes as a segment whose endpoint is a vertex of a triangle and perpendicular to the opposite side. So we said, just kind of like right here, right? We said it goes perpendicular from a side to that vertex. So let's draw it over here. So we said perpendicular, okay? Perpendicular from a side to that vertex. So let's start from the vertex. Let's just go straight down. That way we have it perpendicular, right? And we're going to do that to show that it is perpendicular. So it goes from the vertex to that. So now let's start from this one, right? So we need to go straight down to that. Okay, so if we turn our paper, we can see that we're going to go straight down like that, right? And then we're going to do a 90-degree indication to let us know that's a altitude, right? So nobody has to guess what angle. Okay, next to the last one. Let's start from here, and we're going to draw it down over here. Okay, and as it turns out, it looks almost perfect, right? We're going to say that one is perpendicular. So it's perpendicular from the base up to that vertex. That's called an altitude. Okay, so wherever those three cross, that's called the orthocenter. Okay, so these are our 4 points of concurrency. Okay, so depending on what we do, if we started with 3 perpendicular bisectors, right? Bisector means that it's right in the middle, right? And it's perpendicular. That's going to create the circumcenter. The incenters are created by angle bisectors, right? So we bisect the angles wherever they cross is that incenter. The third one is the centroid. That's created by medians, right? We start in the middle, go to that vertex, wherever those 3 cross, it's the centroid. And then the last one we said was the orthocenter. It's created by going from the vertex to a perpendicular at the base. So those are called altitudes. So those 3 make the orthocenter. Okay, so those are our first 4 right there. So let's go ahead and think about that and apply that on the second page. Okay, so we're going to match which ones of these matches up with this. So let's just kind of go through each one and see what it. Let's analyze it. All right, so let's look at A. What do we know? It's going from a vertex, right, to the middle, right? Because we know this is equal to that, right? And this is going from a vertex to the middle of this side, right? Because that's equal to that. So for vertex to the midpoint, right? What did we say that was? Okay, so we said from the vertex to the midpoint. Okay, so from the vertex to the midpoint is called a centroid, right? So let's go ahead and go over there. So that's going to be A. So centroid. Okay, so vertex to the midpoint. All right, so on B, let's look at B. B, what do we got here? We see this is perpendicular, right? So from the perpendicular base up to the vertex, perpendicular to the vertex, right? So which one is that? Let's look over here. What did we say? We said, we said perpendicular to the vertex is an altitude. Okay, so that's going to be, so B is going to be, altitude, and it creates orthocenter. Okay, so on B, we know that's the orthocenter. Okay, now let's keep it moving. All right, so next to last one, we have C. Let's look at C. What do we have on C? C looks like these are perpendicular, right? And it's at the midpoint, right? So that's the midpoint, and it's perpendicular. So we said midpoint, and it's perpendicular. Which one is that? Well, let's look. Okay, so we said. All right, so let me squeeze this in. All right, so we said midpoint and perpendicular. Midpoint and perpendicular gives us our circumcenter. Okay, midpoint and perpendicular 90 degrees because this is a circumcenter. So that's going to be C would be for A. So we know D has to be D, but number 2. But let's check it out. What do we know? We don't know if that's the middle, but we see here, right? This is bisecting the angle. This makes this into one with 1 arcs, right? These are 2 with 2 arcs. Those are 2 with 3 arcs. So this is angle bisectors. All right, and we know that angle bisectors are the incenter. We know that has to be the last answer. Okay, so that's what we want to do to analyze those, is we want to be able to go from here to figure out what those are. That's what they're going to ask us to do on the DCP. All right, so let's go and put it all together. Let's think about what we talked about on the first page and this, and match these up. So we're going to look at the diagram and see which one it is. So let's analyze this again. Okay, so once again on this one, we have perpendicular, right? And this is equal on either side, so we have perpendicular bisectors. Oh, let me write it over here. These are all perpendicular bisectors. Okay, so what did we say makes perpendicular bisectors? Those are the It creates the circumcenter. That's it. All right, let's look at this one. Okay, what do we see over here? These are dividing the angles, right? So we call those angle bisectors. Okay, let's look at our notes. What do we say for angle bisectors? We said angle bisectors create a incenter. Okay, it's as simple as that. We're just doing some analyzation, right? Let's look over here. What do we know about this? This one is perpendicular, right? But it's going perpendicular to the vertex. Perpendicular to the vertex, we call those altitudes, right? So the altitudes create the orthocenter. Okay, and moving right along. Okay, see how many of these you can get on your own, actually, first. All right, so then let's look at this. What do we have? These three lines, right? What do we know? I know it's in the middle, right? So it's a bisector. Okay, so it goes, but I don't know anything about this angle, right? So it just goes from the midpoint to the vertex. That's going to be called the median. Those are all medians, right? So from the vertex to the midpoint, those create the centroid. All right, so hope you got all four of those. Now let's kind of step it up going backwards the other way. See if you can get all four of these on your own. Okay, so point D is the circumcenter. So if I tell you that's the circumcenter, what do we know about these? Okay, we don't have any other labels, but we look back at our notes, right? Our notes tell us circumcenter, those have to be perpendicular bisectors. Okay, let's check out on this one. What does it say? This says it's the incenter. Okay, what do we know about the incenter? Incenter is created by angle bisectors. All right, let's keep it moving. Orthocenter. What do we know about an orthocenter? Orthocenter are created by altitudes, right? Okay, and lastly, what do we know about this one? This is the centroid. Okay, what do we know that creates a centroid? We said a centroid is created by medians. Okay, so that's what's going to be expected of us to do. So just look at our good notes, and that's all we got to do to get those answers. So make sure you do that delta math practice to at least our minimum goal. Let me know if you have any questions or come to tutoring. Thank you.